Hello students and welcome to IP Study Lecture videos. In this video, we are going to cover the third chapter of grade 6 mathematics and the name of the chapter is number play. Students, first of all, let us see what are the different topics we are going to cover under this chapter. So student, we will see how numbers convey information in our daily life. Then we will see how we understand the concept of supercells. Now next will be identifying the pattern of numbers on a number line, and next will be the pattern of digit sum of a number. Yes, and then we'll see how numbers are some numbers are palindromic in nature, that is they read same in backward and forward direction. Next will be Kaprekar's constant, and next see how clock and calendar also convey some number pattern, and we'll see how to add and subtract 5-digit numbers using mental maths, and we'll see how to find out the Collatz Conjecture rule. Yes, and then the next topic will be estimating the value of an operation of a numbers. Yes, and the last topic will be games and winning strategies, students. So first of all, let us start with the first topic, that is numbers can tell us things. Yes students, now we know that numbers are not just we use in maths, they can also convey some information related to what they are used for. For example, here is a situation where there is a fruit market and vendors has written some value of numbers for every different vendors. They have different numbers for, like vendor A has 10, then vendor B has 5, vendor C has 0, and vendor D has 3. So what does these numbers represent? So these are numbers for different type of fruits. It means vendor A has 10 different types of fruit, vendor B has 5 different types of fruit, vendor C has no fruits, either he had not come up with the fruits or the fruits have been sold out, and the last vendor D has 3 different type of fruits. So here a number is given and it is only said that this number represents different type of fruits. So we can convey many information and interpret many information regarding to the number that we are using over here. Yes, so for every scenario we can assign some numbers and there will be some rule that can be interpreted using that number. Yes, then the next topic is supercells. Student, first of all, let us understand what is a cell. So cell is a smallest unit of a grid or a table. Let's suppose if we have a table of 2 rows and 3 columns, it will look like this. Now the smallest unit, the single smallest unit is called the cell of that table or grid. It can be of any shape, rectangle, square, hexagonal. Yes, so cell is a part of table, the smallest part of the table or the single unit of a table or grid. Yes, now a cell can contain numbers. We can use cells to write numbers. Now there is a rule that if in a table or in a cell, let's suppose if there is a table and in each cell we have some numbers written over it. Yes, now if we observe those numbers, and the rule says if a number is written in such a way that numbers in its neighbors are smaller than the target numbers, then the number is called supercell. For example, here we have 689 and its neighbors are 512 and 577. Now these two neighbors are smaller than 689. So 689 can be considered as a supercell. So if any number has a neighbors which is smaller than the number itself, then the number can be considered as a supercell. Now students, sometimes the table will be horizontal only, but sometimes table can look like this only. Now in case of table where there are rows and columns like this, here also there are rows, but that rows is 1 only. So if number of rows and number of columns are greater than 1, then what we can do is we have a rule that neighbors mean the numbers on the top, bottom, left or right of the numbers. Like for this number, if I have to check if it is a supercell or not, I have to compare with this number, then this number, then this number and this number. And here we can observe that this number is bigger than all of its neighbor, so it can be considered as a supercell. Here we have two deduction, which says if there are odd cells, like number of cells 1, 2, 3, 4, 5, 6, 7, 8, 9, if there are odd cells, then we can fill the cells of the table with maximum number of supercells in n plus 1 by 2 ways. For example, here we have 9 cells, so the maximum number of supercells that this table can consist is 9 plus 1 over 2, which is 10 over 2, which is 5. Similarly, there is a rule for even number of cells also. Clear, children? So this is the concept of supercells that you can go through and solve this example or questions given over here. Yes. Now, patterns of numbers on the number line. Student, we know that from our previous classes also that a number line can be used to represent numbers. So first we understand natural numbers in our earlier class, then there comes whole number, and in this class you will later part of the chapter will see integer or integers on number line. So there are number line and there are pattern on number line that we can observe. Like let's suppose if I want to represent numbers from 500 to 10,000, then I cannot have a long number line like that representing 5,000, 5,001, 5,002. So in place of that, what we can do is we can write it like 5,000, then 5,500, 5,500, after it 6,000, then 6,500. So we can divide a number line in various ways, but the pattern will follow in each case. Like here we have a number line where the number line start from 1000 and it goes up to 11,000, and each time there is an increase of 1000 on the number line. So if we want to find out a number between these numbers given over here, like let's suppose if we want to locate 5,550, then this number will lie in between 5,000 and 6,000 and will be closer to 6,000 because it is greater than 5,500, so it will be slightly more closer to 6,000 as compared to 5,000. So student, there are numbers that are listed on the number line and you can use those numbers to find out if there is a missing number, or if you want to represent a number on the number line, then you can take required number of differences on the number line. Yes. Now moving to the next topic, playing with digits. So students, sometimes different numbers result into same sum of digits. Like let's suppose if we have 24 and 33, both has same sum. Digits of sum is 6 only for both of them. So sometimes many numbers can result into same sum of digits, and this is also a fascinating property of numbers. Clear, student? So here we have a question which says calculate the digit sum of 5-digit number, that is 42,378. And what we can do over here, so what we can do is we can just add these digits and we can find out the sum of the digits. Yes, so 4 plus 2 is 6, 6 plus 3 is 9, 9 plus 7 is 16, and plus 8 is 24. So there can be more numbers which can result in the same digit sum, that is 24. Yes. So the next topic is pretty palindromic numbers. So student, we already know that some words read same, either we read it in the forward direction or in the backward direction, like wow. So from right, if we move from left to right side, then also it is read as wow, and if we go from right to left side, then it is also wow. So similarly, there are numbers which read same from backward and forward direction, and this is a quite fascinating property of numbers. Like suppose if we have a number 525, and if we read it like this 525, 525, and also if we read from the right hand side to left hand side, it will also be 525. So you see that some numbers have such a fascinating property that they can be read in both direction in same way. Yes. So here are some questions to identify either the given numbers are palindromics or not. Okay. So the next topic is magic number of Kaprekar. Yes. So he is a mathematician from Maharashtra, which you can find out in the book also there is information regarding him. So he has found out a number 6174 and give a rule that every number which go through the Kaprekar process will result into this constant only, and this constant is called Kaprekar's constant. Yes. Now, and what is the rule? So the rule is you have to take the number, and the number should have at least two distinct digits. Like it can be like this. Here at least two digits are distinct. Or let's suppose if we have a number, then these two digits must be different. All the digits cannot be same. There should be at least two digits that is different. Yes. Now, like 3, 3 and 3, 5, this can also be used to apply the Kaprekar's constant. But let's suppose if we have a number like this, we cannot use this number. Yes. So it applies to the number having at least two different digits. Yes. And what is the process? So process is you have to find two numbers using the given numbers. First is finding a number, the smallest number, using the ascending method of arrangement of the digits. Like let's suppose if we have 3, 5, 2, 4, then find out the largest first or smallest first. Then here we have smallest numbers that can be formed using these digits, that is 3, 5, 2 and 4. And if we subtract these two numbers or find the difference of these two numbers, so if we use the resulting number and apply the same process again, after some time of applying the process, we will reach this constant, which is 6174. And this is a quite fascinating property which is identified by our Indian mathematician Kaprekar, that hails from Maharashtra. Yes. Now, so student, the next topic is clock numbers and calendar numbers. So student, time and date also show some patterns. Let's suppose if we have a date that is 5/10/2015. Yes. Now, if you go through this date, then you can find out that this date is palindromics. Yes. So if you read it 5, 10 and 2015. So dates also have some fascinating pattern hidden inside them. Yes. Sometimes time also show palindromic patterns. Like if we have a time 10:01, it can be either in the morning or in the night. So if we see this, we can see either we read it in the right side direction or from right to left side direction. Both will read the same value, that is 1001, 1001. So dates and time also show some patterns in it. Yes. Now, there are some time and dates using which you can make numbers of certain number of digits. Yes. So here we have given like this. You can find out the difference between the smallest and greatest number that can be made using the digits, using the dates or times. So we can play and find patterns in these dates and times. Yes. Now, moving to mental maths, addition and subtraction. Students, there are various methods to add or subtract two numbers. Yes, like we can add them horizontally or we can add them vertically. But sometimes if we use tricks to add and subtract numbers, it will make the process much easier and faster. Like to find out the sum of these two numbers, 42,378 and 15,649, what we can do is we can break these two numbers in their place value. Like we can write 42,000 over here, then we can have 300, 70 and 8. Similarly, the representing the 15,649 using its expanded form, we can write like this. Now we can add these individual place values and we can find out this sum easily, like demonstrated here. So the sum is here given for the 42,000 and 15,000. For hundreds we have 900, then for tens we have 110, and then we have 17, and at the last we can add all this to get our final answer. So using these tricky methods, we can find the sum more easily and more faster. Yes. Now moving to the next, playing with number pattern. Students, sometimes numbers can be arranged in such a way that there can be some rule that is defining those numbers. Like if we see these numbers given over here, we have 9, 10, 11. Yes. So it means the number is increasing by 1. Here also by 1. Yes. Now if we see that here the numbers are getting subtracted by 4. So if we want to find out the number after 9, here we can subtract 4 from 9 and we'll have 5. Then we know that the numbers are increased by 1 every time as we go down. Yes, so it will be 6 and then 7. So there can be many pattern, either multiplication of 2 or division of 2 or multiple operation into 1. So you can go through these examples and solve the questions also. Yes. Now let's move to the next topic, the Collatz Conjecture. So this is also a mystery, and this state that if we go through the process of Collatz Conjecture, then we will reach 1 every time. For any number, if we use a process given over here, then we will always end on 1. And what is the process? So there are two processes. One is for odd number and one is for even number. So let's suppose if you have a number n, and let's suppose it is 5 or 6, it can be either odd or even. So if n is even, divide it by 2. So let's suppose that is n is 6. So if you divide by 2, it is 3. Then check the resulting number is odd or even. So it is odd. If it is odd, multiply by 3 and add 1. Again we have a new number. Apply the same process. If it is odd, then multiply by 3 and add 1. If it is even, then divide it by 2. Applying this process again and again will finally lands on the number 1 always. Like we have a number 6 over here, and if we apply the process of Collatz Conjecture, then after applying some steps we will reach 1 over here. Yes. So this is quite a fascinating hidden mystery of numbers. Yes students. Now so student, next topic is simple estimation. Students, sometimes instead of finding out the exact value, we need estimation of quantity or money. Like let's suppose if you go to a market and you have 1000 rupees in your pocket, and there are two items that you want to buy, and one is costing 560 rupees and other is costing 400, then mentally you can do the calculation that it will be around 900 and will be less than 1000. So you can then just apply the scenario and you can check if you can buy or not. Yes. So it will help you in finding out the decision. Yes. So suppose if we want to find out the sum of 328 and 671. So instead of finding out the exact value, we can round off these two numbers to the nearest possible place value. Like we will take the leftmost digit and round it off. So either we will round up or round down. What does it mean? It means if we have a target number, we have to check, or target digit, we have to check the next digit if it is greater than 5 or less than 5. If the number is 5 or greater than 5, we round up. It means the target digit will be increased by 1. If the number or the digit next to it is less than 5, like 4 or 3, we keep the number as it is and we put zeros for the rest of the numbers. So for example, here we have 328. What we can do is we can write 3 because the next number is 2, which is less than 5. So we can write 0 for the other numbers. Next, for 671, we can see the target digit is 6 and the next number is 7, which is greater than 5. So we'll increase the 6 by 1, which is 7, and we'll put 0 for the other rest of the digit. Yes. Now the sum will be 1000. Now the actual sum is 999. But if we need a quite calculation, then we can use this method and check if we have enough thing or enough value or enough money or not. Yes student. Next and the last topic is games and winning strategies. Students, sometimes to win games we should have strategies. Yes, for better probability of winning the game. Yes, so sometimes it is good to decide a strategy before playing the game. Yes, and we have an example. So here is a game of name whose rules are given here. Start with a pile of object like stone or counter, and let's suppose we have 12 counters or 12 stones, and the rule says players have to take 1 to 3 counters, or for this time we have stones, so either they can take 1 stone or they can take 2 stone or 3 stone, yeah, depending upon what they want. Yes, so the player who will take the last stone, either the whole 3 or 2 or 1, will win the game. So now we want to decide a strategy to win the game. What we can do is we can take the stones in such a way that in the last stage we should have either 1, 2 or 3 to pick up. So here what we can do is we can keep the number of stones in the multiple of 4 for the opponents. Yes, like if we have 12, then let's suppose I take 12 is the multiple of 4. So what we can do is we can take 2, let's suppose 2 stones, then the next will take the 3 stones. So as soon as you can make the opponent to stay on the multiple of 4, then there is a more chances of winning. Yes, so the solution says the key is to leave your opponent with a multiple of 4, like in the last, if you leave the opponent with 4 marbles, yes, based on this condition. Now the opponent can max to max take 3 marbles and minimum he can take 1 marble. So if you take minimum 1, then you will left with 3 marbles. You can take all those 3 and you can win the game. If you take 3 marble, then you can take the last marble. Yes, so if starting with a 12, a multiple of 4, if the starting number of object is a multiple of 4, the second pair can win if they ensure the pile they leave is a multiple of 4. So this is a quite interesting strategies, and different strategies are applied for different games because the rules differ from games to games. So students, this is all from this topic and chapter. I hope you understand the concept very well. We will meet in the next video. Till then, keep practicing, keep learning.